Hey there, and welcome to today's Explainer. Ever looked at a professional weather map and thought, wow, this is literally an alien language? You've got these circles with lines sticking out of them, weird symbols everywhere, and random numbers just floating around. Well, today we're going to crack that code. We are diving into the station model cipher. Meteorologists use these super compact visual models to pack massive amounts of atmospheric data into tiny symbols. By the end of this explainer, you are going to be able to read these like a seasoned atmospheric detective.
Here is our roadmap for today. We're going to cover the cipher's anatomy, cracking the pressure code, reading the trend, visualizing wind and weather, the master decoder, and finally, the meteorologist's toolkit. Section 1. The cipher's anatomy, focusing on the basic building blocks. Let's look at the center circle and the critical left side.
Okay, let's dive in. So imagine a circle right in the center of your page. On the upper left of that circle, you're always going to find the temperature. And right underneath it, on the lower left, is the dew point. Both are measured in Fahrenheit, and they're always stacked vertically like this. The real secret here is how these two numbers interact. If they're close together, that means relative humidity is high and precipitation is extremely likely. But if they're far apart, you're looking at low humidity and dry conditions.
Now, what if you see a station model where they exactly match, say 72 over 72? Well, you've just hit the magic number. That tells us we're at exactly 100% relative humidity, total saturation, which means you're absolutely going to need an umbrella.
Moving on to Section 2, cracking the pressure code using the 500 rule. So sea level pressure is shortened to a 3-digit code on these maps just to save space. To turn it back into millibars, we use a cheat code called the 500 rule. It's pretty straightforward. Step 1, look at your 3-digit number. Step 2, if that number is less than 500, you add a 10 to the front of it. If it's 500 or more, you add a 9. And finally, Step 3, just drop a decimal point right before the last digit. It is such a clever way to save space once you get the hang of it. Let's test this out with the tricky one. The code 000. You'd probably think the pressure is 0, right? But remember the rule, 0 is less than 500. So we add a 10 to the front and drop a decimal before that last 0. That perfectly translates to exactly 1000.0 millibars. Always keep in mind you're dealing with 3 digits for these pressure codes.
Next up, Section 3. Reading the trend, or deciphering past pressure.
Just below the pressure code, you'll find the pressure trend. This is basically a quick story about how the atmosphere has changed over the last 3 hours. You'll see a number next to a slash. A slash pointing up means the pressure has risen. A slash pointing down, it's fallen. And the number right next to it represents the amount of change in tenths of a millibar. So, a 16 with a downward slash literally means the pressure fell by 1.6 millibars. Okay, quick challenge time. Let's say your current decoded pressure is 987.6 millibars, and the trend shows a 16 with a downward slash. What was the pressure 3 hours ago? Well, think about it. If it fell by 1.6 millibars to get where it is now, we just have to do the reverse to go back in time. We add 1.6 back to our current pressure, which gives us a past pressure of 989.2 millibars. Make sense?
All right, Section 4. Visualizing wind and weather, focusing on symbols and sky cover. Now we get to look at the actual shapes branching off that center circle. See that line extending outward? That's the wind staff. The absolute golden rule here is that the wind staff points into the wind. Winds are always named for the direction they blow from. A really great visualization hack is to picture an arrow being pulled by the wind. It lines up to point right back at the source. So if the staff points straight up towards north, you've got yourself a north wind.
Right at the end of that staff, you'll notice these small lines or triangles. We call those barbs, and they tell you the wind speed in knots. Honestly, it's just basic addition. A short half line is 5 knots, a full single line is 10 knots, and a solid triangular flag, that is a whopping 50 knots. So if you're looking at a staff with one flag, one full line, and one half line, you just add them up. 50 plus 10 plus 5 gives you a very windy 65 knots. And let's go back to that center circle for a second. It acts exactly like a pie chart for sky cover. It visually fills up with ink to represent the percentage of clouds overhead. An empty circle, totally clear skies. A half-filled circle means 50% cloudy, and a fully solid black circle means it's completely overcast. It is incredibly intuitive once you see it. Tucked right between the temperature and dew point, you'll find the present weather symbols. A dot is rain, a star is snow, a comma means drizzle, an equal sign is fog, and this cool little lightning bolt K-shape, that's a thunderstorm.
But what's really clever is how they show intensity. Stacking multiple symbols means heavier conditions. 1 dot is light rain, but 3 dots stacked vertically means heavy rain. Same with fog. 1 equal sign is light, but 2 stacked equal signs means heavy fog.
Which brings us to Section 5, the Master Decoder, where we put it all together.
It's time to test out our individual rules on some real-world data. Take a look at this scenario from LaGuardia Airport. We have a temperature of 43, a dew point of 40, an infinity symbol indicating haze, and a 3-digit pressure code of 146. Based on everything we've just covered, what is the exact barometric pressure in millibars? Take a second and mentally apply the 500 rule to that 146.
Did you figure it out? Well, the number 146 is less than 500, so we add a 10 to the front and drop a decimal right before the last digit. That gives us an exact sea level pressure of 1,014.6 millibars. If you nailed that, you are officially well on your way to being a master decoder.
Let's try breaking down a more complex model for Albany. Here, we see a temperature of 56 and a dew point of 54. Those are incredibly close, right? So we immediately know relative humidity is near 100%. The circle is totally filled in, meaning it's fully overcast. Our pressure code, 019, decodes to 1001.9 millibars, and the trend shows a downward slash of 21, meaning pressure fell 2.1 millibars in the last 3 hours. So falling pressure combined with high humidity, that clearly signals we've got an approaching storm system.
Finally, Section 6, the Meteorologist's Toolkit, covering instruments and predictions.
We've spent all this time decoding the map, but let's connect these symbols back to reality. Every single symbol on our model links to a physical instrument. That tricky pressure code, measured by a barometer. The wind barbs showing knots, captured by a spinning anemometer. The dew point and relative humidity are often measured by a sling psychrometer. And data for upper altitudes, that's gathered by a radiosonde, which gets carried way up into the atmosphere by a weather balloon.
And here's why all of this matters. Knowing how to read these measurements lets you predict incoming weather without a single screen. If your barometer shows falling air pressure, a storm is likely approaching. If your thermometer shows dropping temperatures, a cold front might be moving in. Noticing the dew point getting closer to the temperature, you can absolutely expect precipitation. And a sudden shift in wind direction often means a weather front is passing right over you.
I absolutely love this point from the source material. Even without a phone or computer, you can predict an incoming storm using basic instruments. Learning this cipher isn't just about reading a map, it's honestly about empowerment. Decoding these variables transforms you into a real-time atmospheric detective, perfectly in tune with the environment around you. We've covered a lot of ground in this explainer today, from the 500 rule to reading wind barbs. So I'm going to leave you with this. The next time you step outside and look up at the sky, what hidden atmospheric data is just waiting for you to decode it? Look at the clouds, feel the wind direction, and remember, you now have the cipher to read the weather like an absolute pro. Keep practicing and stay curious.